days. So first of all, thank you very much for participating. I'm Giulia Di Bari and from Crete, and I coordinate the exploitation and standardization activities within the Rossini Project. The Rossini Project is hosting the organization of this workshop, which is part of a standardization workshop series that we are organizing within the hybrid production system cluster. So this is the agenda of today. There's a small introduction from Crete, a welcoming. Then we will leave the floor to our speaker that will provide you with information about the COVR project, the current state of the art of standards in the field of safe interaction. Then we will provide you with an update and some information about standardization activities carried out into projects of the cluster, the SHAREWORK project and the Rossini project. The workshop is expected to end at 4 p.m. After 4 p.m. there is a meeting just for the Rossini partners that we have decided to call after this workshop for a better organization of the activities, but it is just a reminder for the Rossini partner. So before starting with our speaker, I would like to give you a very quick introduction about the Rossini standardization activities, which are led by Crete and have started since the beginning of the project with the purpose of understanding how the Rossini project can contribute in terms of standardization and possibly bridge the gaps of existing standards thanks to the technical activities that we have been delivering up to now. The standardization activities of our project will be collected in a final public deliverable, which is the standardization roadmap that will be released by March 2022. So the standardization activities of our project have started, as I said, since the beginning of the Rossini project, when we started mapping standardization opportunities and we started having contacts with national standardization bodies to understand how the Rossini project could give its contribution to the world of standardization. Of course, we wanted also to engage our partners in these activities, and we had brainstorming and workshop activities with the Rossini partners, which allowed to identify a so-called standard park, that is a list of standards that the Rossini project can contribute to. And this was the result of brainstorming within our consortium. And this is the starting point for the setup of a standardization roadmap that will be the final deliverable of our project. Of course, standardization activities are better delivered when we cooperate and when we can discuss and exchange activities that we do with other associations and organizations. And this is the reason why we gladly entered into the hybrid production system cluster and are now cooperating with the COVR project because of exploiting this opportunity of discuss together about this important issue. Other initiatives have been carried out until month 30. For example, Fraunhofer, which is a partner of the Rossini project, has entered a joint initiative with the COVR project, presenting the activities that they have been doing within the Rossini project that were presented and submitted to an ISOPAS, so to a standardization document, and I would not anticipate anything because it will be discussed in the next presentations. What we have been doing starting from month 31 is defining a series of activities with clusters and associations and other partners and projects to enrich our standardization strategy. And so we have planned 3 workshops. And the first one is today's workshop, which is about safe interaction. And the other 2 will be possibly in September and in November 2021. The topics that we identified from these workshops are the ones that were considered by the Rossini Consortium as most relevant for the consortium, but that were then shared and approved also by the members of the hybrid production system cluster. And these are safe interaction, which will be discussed today, ergonomics, and machinery. So I will give you further information also on the following workshops in the next weeks. Our purpose is so using all these activities, all the result of all our workshops and joint activities that we are leading to define a roadmap that will be then shared, of course, within the Rossini consortium, but also with the partner, with the organization and clusters we are collaborating now. The final roadmap so will be ready by the end of the project, as I said, March 2022. And this is just to summarize you the ongoing activities that we are carrying out within standardization. So we have 3 workshops. The topics are the one that I presented you before, so safe interaction, ergonomics, machinery. Every workshop will be we see the participation of an expert, so of a guest speaker presenting the state of the art of standard in a certain field, but also the contribution from project from the hybrid production system cluster. We are collaborating with the COVR Project, and today Aske will give you some information about an initiative launched by this project, which is the COVR Hub. And at the same time, we are also organizing further other dissemination activities within the hybrid production system cluster, which is formed by 8 Horizon 2020 projects working in the field of collaborative robotics. And in the next weeks, we will give you also further information on these joint dissemination activities. So this is my presentation. Now I will stop sharing with you my screen, and I'm very, very happy to let our speaker start the discussion of today. So I leave the floor to Aske Lassen from the Danish Technological Institute. So Aske, when you want, you can start sharing the screen and your presentation. Thank you very much.
All right. Thanks, Julia. Do you guys see my screen?
Perfectly, but not in a presentation. Okay, now it is also in the presentation mode.
There we go. Okay, excellent. So good afternoon, everyone. My name is Aske Bach Lassen, and as Julia said, I'm from the Danish Technological Institute, or DTI in short. I have the privilege of coordinating this project called the COVR Project. It's a Horizon 2020 project. I will address 2 topics. So one is what is COVR, and the second is what are COVR hubs. So hopefully after these 15 minutes, you'll be able to know the answer to those 2 questions. I see a few familiar names on the list of participants. So if you already know about the project, that's great. But I think many of the others of you are not familiar with the project at the moment, I would expect. So if you have any questions while I'm presenting, please interrupt. I think that's more fun. So by all means do so. Just speak, because I can't see your faces when presenting right now. So what is COVR? Before I answer what is COVR, I think I'm just going to put a few words to why COVR is needed and the situation that we're looking into today and also in the future. So we definitely see an increasing number of cobots on the market, actually a quite aggressive growth in the coming years. We see that robots go way beyond manufacturing, and that robots or cobots are becoming easier to program, which means that they target audiences with little or even no robotics experience in the past. We see increased human-robot interaction, and we are seeing very blurred line between what is an industrial robot, what is a cobot. Is cobot even, a clearly defined term? Currently, I would say it's not. Everybody has their own idea about what a cobot is. And then we also see a large social need for cobots, and most obviously it's in the healthcare and the rehabilitation domain, but also other social areas. So what does this mean? It means that we see more and more cobots. We see people that are less experienced working with them, and we see them being implemented in domains that have previously been outside the typical areas to implement robots. And that will bring on a lot of challenges with safety. So the COVR project tried to be an enabler for this growth. We try to promote safer cobot installations and accelerate the launch of new cobots. So we see a lot of new cobots being launched. almost on a daily basis in these years. And then lastly, but not least, we want to make it easier to distribute cobots on the European market, so make it more even playing field. So how do we do that? First off, we set up the project, and we are these 5 partners you see here: DTI, RD in the Netherlands, CA in Paris, France, CNR in Milan, and Fraunhofer IFF, who's also a partner in the Rossini Project, I can see, are also in the COVR Project. And we have 4 main activities, and that seems very simple, but the ideas behind those are actually not that simple. So first off, we have created what we call shared safety facilities, or SSFs in short. What is that? It's basically labs where we have the equipment needed to conduct safety measurements. So let's say that you have a collaborative robot, you want to see the maximum force that it can exert in a given programming, then you need some equipment. We have that in these SSFs. We have quite a lot of equipment across these 5 partners. For most cases, we have the same equipment at all 5 partners, which means that should you go to DTI, then you would have your measurements done by the same equipment as if you went to Italy and asked for the same safety validation. Then we have something that we call protocols. And it's not in any way that I'm saying that we invented the term protocols, but in our case, these protocols are step-by-step guidelines on how to measure safety. So you have the directives. If you're looking at the regulatory landscape, you have directives at the top being the law. You have to comply with those. That's obvious. To do so, typically you would say that you use the thresholds, all the details that are given in the standards. These are not legally binding, but it's usually a pretty good way to document that you did your very best to ensure safety, that you followed the standard. So that's why most people do that. In the standards, you will find thresholds, limits of sorts. So that can be, if we take the example from previously as well, if you get hit by a robot in the torso, you will see that there's a certain threshold, certain limit value that the force has to be below, the force and pressure. And that's very good. And for some of the requirements in the standards, there are at least some guidance to how to test this. But in most cases, actually, there aren't. So you're left with this limit value that you have to be above or below, but there's not really a standard way of doing the measurement. And that's obviously an issue, because how do you then ensure that you comply? And that's where these protocols come in. So they will be very, very low practical and say, you need this piece of equipment, you need to mount it like this, you need to do the collision like that, then you need to process the data in this way. And then it will give you an answer. This is the force that your robot is exerting, and then you can yourself look to the standard and say above or below. Yes. A very important point to stress here is that the protocols are not in any way replacing the standards. So it's a way to validate the requirements in the standards. So the protocols doesn't say the limit value should be this or that. That's still in the standard. I hope that makes sense. But it's a very important point. Morten will get more into that later, I believe. Then we created an online learning platform. It's actually here. It's called safearoundrobots.com. It's a very good platform. I would even go as far as saying it's the best place on the internet for information related to cobot safety. You can find case stories there. You can find a very, very useful tool for finding directives and standards. I think Morten will show you as well. And there's overall a lot of good content in there. It's free to use, so by all means, get familiar with it. And then finally, the 4th ingredient in our little recipe here is conduct projects with the industry. So from the very beginning, it was very clear to us, standard safety is tricky, and there's a lot of different cobot types. We need to know what's actually happening in the industry. What are the challenges? So we conducted 60 projects with the industry to refine the safety facilities, the protocols, the learning platform, to implement all the experiences that we had through these projects. So this is basically the formula that is the COVR project. So the awards are at the center. It helps us write protocols, establish safety methodology, establish these shared safety facilities. But actually, I think this might be interesting for you, but it also helped us develop commercial services, because what we do in these awards is very similar to what the industry is needing. Obviously, we requested exactly that in our open calls. And that means that based on that information, we've been able to conduct quite a lot of commercial projects on the side of this Horizon project. And it's been quite diverse what these commercial partners have requested. Some of the OEMs, so the robot manufacturers, want safety design consulting. Some want us to validate the safety of their system. Some end users are interested in validation as well. So test, we have had this implementation by our system integrator. Is this safe enough? And then a lot of training has been needed as well. These are a few of the projects that at DTI we have completed. So one thing that you might notice here is that it's a very different type of robots that we're looking into. So in COVR, a collaborative robot is any robot that shares workspace with a human. So we've seen quite a lot of mobile robots. We've done projects with virtual reality and how to use that to validate safety. We had quite a lot of projects with artificial intelligence. So as you might already be familiar with, it's very hard to document that a system based on AI is safe, because you never know how it's going to react on an unknown circumstance or a new environment and such. But very diverse range of projects that we've completed. All the information again is put on that toolkit, and I'm actually serious when I said it is the best place on the internet for safety. So we actually have 1,300 monthly visitors to the website, and people are staying there quite long to actually find information. So very useful. All right, so that was a quick introduction to COVR. So these are the 4 activities that I mentioned before. This has led to a very strong and common approach to safety across these 5 partners. But we are at the end of this project. I didn't mention that before, but we've been running for 3.5 years. And we want to sustain this. We want to keep being leading organizations on safety. That's also due to the good commercial track record that we received with this information, but also because we believe that having a strong network of safety across Europe will be a benefit to all. So we want to expand the network. So right now, these are current candidates. You might know some of these organizations, but we want to expand even more. And what am I actually talking about here? All right. So you saw this one before with the commercial projects. We want to keep having protocols written. We want to improve our safety methodology. We want to improve our shared safety facilities. But we won't have these COVR awards, which obviously was funded by the Commission. We won't have them going forward. So this development needs to be funded through our commercial activities. And we found that commercial activities from the 5 COVR partners have been limited 95% to a 200 kilometers radius from our physical location. So we almost only service customers within that vicinity. So that means that we won't be stealing each other's business by teaming up. On the other hand, we'll be sharing a lot of information that makes us more competitive in going into the market. And we'll ensure that common methodology, that means that safety is tested the same way in Spain as it is in Poland, as it is in Denmark, which makes it more even competition for the companies. So what do you get, which if you join as a COVR Hub, you get some best practice, common approach to safety, you get educational material, and you get training for your organization. You get guidance on which equipment to purchase. You get this close community where we share information, and you get to brand yourself as a COVR Hub. And what are we asking for? No money, which is typically a good starting point. But obviously, we are asking that you sort of follow our approach to risk assessment, our approach to safety, and generally the approach that you develop a protocol to actually measure that things are safe. You don't just assume it. We have a letter of intent covering that, but it's very loose, so it's quite easy to get on board. So, which types of organization can join in? It's basically all organizations that want to do safety testing, safety validation. So you need to have an ambition to either do some research and development on that topic or commercial activity. And you might want to have some equipment to do measurements over time. If that sounds like you, so this could be either an RTO, it could be a university, or it could be an industry partner. So I saw Pilz on this list, so obviously I think it would be interesting if you guys were interested to join. But it can basically be all organization types. So if you're interested to join, contact me. I think my email will be in the participants list here from this meeting. And then we can either invite you to an onboarding day, an information day, or we can even share the letter of intent with you straight away if you're interested. All right. Sounded like a sales pitch, but we are not making any money on this. And that's actually all for me.
Thank you very much, Aske, for your presentation. It was really interesting to listen to what you said. So now I will leave the floor to your colleague, Morten Künrich, always from the Danish Technological Institute. Morten is going to present you the state of the art of standards in the field of safe interaction. So when you want, you can start your presentation. Thank you very much.
Yes, I'm unmuted, and so I will just briefly go over some of the developments. So first, what is safety? What is safe? Then a little bit about a larger picture on standardization, and then some trends and more details about the protocols that Aske mentioned before. So we have repetitive work, which is maybe not immediately unsafe, but which is unsafe over time because you get damages over a longer period of time. Then you can try to help some of these problems with exoskeletons, for example, but that can maybe lead to some new hazards. So in this example, he's using power tools in combination with his actuated exoskeleton. So hopefully the actuators will do what he believes they are doing. In COVR, we have also developed some testing protocols for the force limits of an exoskeleton, and also the motion of range of the individual joints. So these are some interesting properties arising from that field. And then you have a co-worker, a co-part with some tooling. And we can see that safety is actually also the cell layout, how you place fixtures in the cell. It is also tool design. Safety is also a question about the work items you are handling. So there are a lot of new things to consider. I'll just continue a little bit. Here we have an example of some internal clamping hazards within the robot. So it could be design measures on the robots themselves. A little bit more on the, can you see my video? Yeah. So here you have a tool that is inserting screws, and this tool has a built-in safety function, so that when it detects a hand, it stops its motion, and you can see that it's possible to lift the tool free because it has a linear guide. So it's actually only gravity that pulls down the screwdriver in this example. So it's sort of an example of some inherently safe design. Things can get a bit more messy when you have combination with CNC machines. So here we have some music, and it is inserted here. It is cut and moved back, so yeah. And I think the rationale out there for many people is that it's unsafe to tend these machines. So it's just very good for us that we have a robot that now can do that. And then there's a little downside that when things maybe go wrong in a cell like this, that a work item is stuck somewhere and somebody enters the cell to help the application to run, some new hazards can arise. And the last example, here we have some robot welding. So it's a collaborative robot with that is handling a robotic gun. And then on the right-hand side, we have an example of what can happen when you try to weld with a robot. So you saw a funny movement there. It went a bit fast, and it probably has something to do with the currents that you have when you try to weld stuff and robot joints. I can see that there is an American national standard for how to make safe welding applications, but I'm not aware whether we have that in ISO level, for example. The World Trade Organization is an organization that works on creating free trade in the world, and a part of their initiative is based on standards. So the national standardization bodies are sort of measured against one of the agreements that comes from WTO, and basically we want to be capable to trade, and we need standardization for that, so that we, for example, a standard USB standard is nice when you want to attach different devices to a computer, but you also want it to be safe. So here we have sort of the balance that you want these standards to be so that you can use them, and they enable free trade. On the other hand, you also want safe products. So this was the only icon I could find, and this is maybe not that balanced, this particular icon, but there is some balance. Some would actually say that it has tipped towards the safety part of the range. So when you in the Rossini project talk about making new standards, maybe also have this in mind. To give an overview of what the landscape could look like, then you have different user limits that will guide you to different directives, at least in the EU. And under the machinery directive, there are two paths. You can go either you are in a public setting or in an industrial setting. And if you are in the industrial setting, then we have standards for robot arms ISO 10-18. It is heavily revised at the moment, and there's a lot of work going on there. ISO TS 15066 is a technical specification that defines pain onset values. So it's not a matter of values for when people get hurt, but it's more when will people feel pain in the interaction with a collaborative robot. So it's forces in Newton and it's pressure that we're dealing with there. There's also a technical report 2218-1 about tool design. So it gives advice on how to do inherently safe tool design. And that particular standard, it's not a standard, it's a technical report. We expect that there will be more work put into this, and it could maybe become a standard soon. So just to say that there is an opportunity in that particular document. On On the mobile side, you have ISO 3691-4, which is actually a standard for industrial trucks, autonomous industrial trucks. And many of the mobile platforms fall into this category. And much of this standard has been defined with these smaller mobile robots in mind. Yeah, and then you have general standard for risk assessment 12100, which is a sort of the mother standard for these different standards I've just mentioned. In public domain, you have the standard 13842, which is for personal care robots. And the requirements there are a lot more strict because you get in contact with untrained operators. They're not necessarily operators, they can also be visitors to an elderly home or a visitor to a hall where a cleaning robot is moving around in the public. There are some standards for functional safety that are used from these different branches. So 13849 and also the 62061 are two examples of that. So yeah. So some trends in standardization. The requirements for these pain values that I mentioned are being incorporated into the ISO 10218 standard. As I mentioned, the mechanical requirements for tooling, there will be more work there. We do not have a standard for the electrical interfaces to the tool of a robot as it stands today, but we expect that some work will soon start in this area. Both cybersecurity and the use of AI in safety functions is something new, which the revision of the machinery directive, which is ongoing at the moment, opens up for. So it's also to say that there are really some possibilities to work in this very interesting area. In COVR, we have tried to tackle this through the definition of a skill. So a skill is something that you want the system to do. It's a sort of a safety measure. So for example, here we have a skill called limit range of movement. And it's an abstraction. We don't say how this is obtained. To the right, you can see different possibilities to obtain this. Mechanical stops at the joint or Cartesian limiting safety functions. So we have these different skills: maintain safe distance, dynamic stability, limit physical interaction energy. That is what we know from many cobots, that it will not hit you too hard, and so forth. We have started two initiatives. So if you want some guidelines or ideas on how to work with standardization, there's a lot of knowledge in the COVR consortium. There is a SEN workshop agreement document that has been started from COVR. It's Dr. Marcel Valori that is leading this work, and it is about how to make protocols. So it's a standard, it's not a standard, but a specification for how to make protocols. There's another initiative in ISO. It's a publicly available specification. So it's a document that you don't have to pay for. You can download it freely, and it's led by Roland Behrens, and it's about how to actually measure forces and pressures. So it's concrete guidelines for how to do that. So I think the last thing we will do now, because the time is also short, is to see what this system looks like, and I should share another screen. maybe I will just share my screen like that. So this is the web page that Aske mentioned, and I can start the toolkit. I can go and see protocols, for example, and here I select the skill that I'm interested in. So let's say I want to maintain a safe distance, and I would like to do so for a mobile platform. Then I get 3 examples of protocols I can use to test this specific skill in combination with a concrete piece of equipment. So I can download, and I will get a test protocol, and it will define some metrics, both define what is the target metrics, what is that you want the system to do, and then also how to measure the concrete values and how to report that. So it gives guidelines on how to perform the test, which equipment you can use, and how to report it. And that is what we have done across a wide range of skills and also equipment types. Something similar is true for directives and standards, because it's very hard to find your way in this. So you can select areas and you can narrow it down to different pieces of equipment, and then get both directives and standards to comply with. So that concludes my presentation.
Thank you very much, Morten. I think also, in my opinion, also the presentation of the trends for future standards was very useful, also for the activities of the project that we are coordinating now. I know that the time is very tight, so I will postpone any question to the end of the workshop, if any, of course. So, or if you have questions, you can write them in the chat, and then we will ask the question to our speakers at the end of the workshop. But now I will leave the floor to Amanda Suo from the Spanish standardization body. Amanda will give a presentation of the activities they have been doing within the SHAREWORK project. So Amanda, when you want, you can start presenting. Thank you very much.
Hello, can you hear me? Yes?
Yes.
Okay.
Yes.
Okay. I'm Amanda from UNI, Spanish Association of Standardization. I will give you a short presentation about the standardization activities that we have realized during these years from 2019 for now, and a summary of our standardization strategy. Okay, implanted in our project SHAREWORK. Okay. First of all, I just want to let you know the main objective of our project about the related to the standardization activities. Our standardization task is to facilitate the acceptance and utilization by the market of development solutions in the robotic industry, and another objective is to provide the a landscape the landscape related to the existing standards in the human report collaboration area, and to ensure the compatibility and the interoperability with robotic industries that have existed in the market through the standards, as well as to use the
Amanda, I can't hear you anymore.
Of the stakeholders. Okay, so our standardization activities planted in this task is to fulfill these main objectives and to develop two specific activities. Okay, the first one is the identification and analysis of the existing standards in the robotic industry, and then another one is to contribute to the future standardization development. Okay, related to our project SHAREWORK. So 2 years ago, we have finished the first activities. We have prepared we have submitted a report about the analysis of landscape of standards related to the project SHAREWORK, and we have identified the related standards technical committees in the in an ISO IEC or CEN or CENELEC, such as CEN Technical Committee 310 Advanced Automation Technologies and their applications, or ISO Technical Committee 299 Robotics, and also like IEC Technical Committee TC, okay, 65 industrial process measurement, control and automation, and also synthetic joint technical committee 13 about the industry security for the product security. Okay, etc. Then I will give you a summary about all of the standards that we have identified related to our project. Okay, so first of all, I want to give you a summary of how we are implementing our standardization strategy. Our this standardization strategies includes 3 parts. And during this is the planning for contribution to standardization. We created we established the first contact. Oh, I'm sorry. Okay. We established the first contact with the technical committees, inform them about our project, and then the second phase is establish fluid communication and interaction with the relevant technical committees. Okay, and the third phase is to contribute it for a future standardization initiative or program or project with the SHAREWORK result outputs. So okay, I told you before, 2 years ago, we have finished the deliverable of standardization landscape and applicable standards in the related to our project, okay, in the robotic industry, and now and then we also did an analysis about the during all of the standards that identified it, we have to a brief analysis of to identify what are those compliance requirements standards, and which compliance requirements standards can be used as guidelines for our project. So for our project SHAREWORK in human reported cooperation, we have identified 36 technical committees, and you can see here in different areas. For example, in industry reports, in advanced manufacturing, industrial cybersecurity, interoperability, IoT, artificial intelligence, health and safety of workers, safety of the machinery, of course, and lighting, or etc. And from these 36 technical committees, we have identified it. Those 46 standards are especially related, especially relevant for our project, and these 46 standards may be considered as compliance requirements for the outputs of the project. Okay, and they refer to the workplace 1, 3, 4, 5, 6, and 10. That means they refer to safety of the machinery, robotics, human ergonomics, human resource interaction, human system communication, automation and integration, software development, data security, safety risk management, and augmented reality training. Okay, but the standards of the first items are more important. Okay, related that the standard related to the safety of machinery, robotics, the communication of the human system are more important. So from all of these standards, which standard can be considered as compliance requirements? We have identified the standards such as ISO 10218 is reports and robotic device safety requirements for industry robots, or some standards in the area of economics. Okay, so in this table you can see which are the standards will be considered as the compliance requirements in the human robotic cooperation area. Okay, the next steps. Now we are in the month 32. So we are preparing the report on the future standardization proposal. Okay, now we still maintaining the interaction with the relevant technical committees, with the ISO or IEC or THIN related to the robotic industry, and to share the information of the standards with them, and make their let there be aware of the advanced activities of our project, and also we are participating to their working sessions, and then in order to identify the important standardizable topics, and then we can prepare a proposal to create a new standard or standards. Okay. Okay. I have selected some relevant standards related to human report collaboration. For example, ISO TC 199, and also THNLEC in the European, okay, their technical committee 44 about safety of machinery, and also, as I mentioned before, ISO technical committee 299 about robotics, and also THNLEC technical committee 310 about advanced automation technologies and their applications, and also okay, except these standards related to automation or safety of machinery, we also identified the importance of the standard in the security, in the industry cybersecurity area. So here I have given you three technical committee, three important technical committee. They are ISO IEC Joint Technical Committee 1, 27 Security and Privacy Protection, ISO Technical Committee 22, and okay, subcommittee 31 about the data communication, and okay, data communication, and IEC TC 57 power system management. Okay. Okay, and here you can see what okay, in the part okay, here we have detected several relevant TCs regarding the important standards. Okay, for example, the ISO 10218 about robotics, or some, okay, or like ISO 14913 related to the safety of the machinery. Okay. Okay, so now we are preparing the next report, as I have told you about the contribution for the future standardization proposal. So we are preparing this report of other partners of our project with Fraunhofer Indra, STEM, the University of Rome, AutoCAD, etc. And here here I can give you a schedule about the next about the actions that we are carrying out. Okay, so what is the next step in the standardization activities for this year? In the end, at the end of the year, we want to organize standardization workshops to prepare proposal of the workshop agreement. So the first of all is to prepare analysis of the development of new standards in the area of human robotic collaboration, and then create that possible workshop agreement. So finally, I will give you the three proposals for about our future standardization proposal. We have identified several topics, and then maybe we will create the workshop agreement topic focused on, for example, the guidelines of cybersecurity for industrial robotics, or requirements of cybersecurity to the extent that it applied to industrial robot safety or safety and cybersecurity requirements for industrial robotic industry, or another topic that we will cover is about safety and security testing for industrial robot. So this is just the proposals. Okay, so after organizing that standardization workshop of our project, we will define which main topic that we will create. Okay. So I think I have given you a very short presentation of our standardization activities, and if you want to more information about how we are implementing the standardization strategy, okay, all of the details about the implementation of our standardization strategies in the project, or what are the details of our planning for this workshop at the end of the year. I will give you can contact me. Okay, I will give you my email. One moment. Okay. So I will give you my email. I will write down my email in our chat box. Okay.
Thank you, Amanda. Thank you very much.
Thank you.
Share with all the participants also the contacts of our speakers. So Amanda, thank you for presenting the activities of SHAREWORK. Of course, we would like to know how you are progressing in the following months and what are your future plans. Now, I will leave the floor to Sebastian Herbster from Fraunhofer to present the activities that he, together with its team and other partners from the Rossini Consortium, are delivering within the Rossini Project. So Sebastian, you can start when you want. Thank you.
Yeah. So, hi everyone. I hope you can see my screen in full screen mode. Okay,
Yes.
perfectly. Yeah, so my name is Sebastian Herbster. I work for the Fraunhofer IFF in Magdeburg for the business unit Robotic Systems. We're partners of the COVR Project. So I also work together with Morten and Aske. And today I'm going to present one of the deliverables we had in the Rossini Project, which is also part of this ISO-PASS project or ISO-PASS process Morten Künrich had presented in presentations before. And it is about a new conversion method to evaluate the hazard potential of collaborative robots in free collisions. No. So let's look in general, what are we speaking about? So we are speaking about the safety in physical human-robot collaboration, and the closest form of cooperation is the collaboration itself. And that means that there can be a physical contact between the human worker and the robot, and this contact can be desired or necessary, but in many cases it's more or less accidental. And to minimize the risk in case of such a collision, power and force limitation is used. And this, in this case of power and force limitation, there are predefined limit values which must be met. And in case they are exceeded, something must be done. So you have to reduce the velocity, change the stiffness characteristics of your robot, or there are many more possibilities. And a typical experimental setup to test this kind of collaboration is that you have to do the experimental validation, which is shown on the left. So you have a measurement device on the right consisting of a force sensor, a spring, and damper material. And this measurement device mimics the biomechanical behavior of the human soft tissue. And you have to have the robot on the left. And what you have to do is you have to do a risk assessment, and depending on which positions there might be a contact between human and robot, you have to measure the contact force and reduce the velocity or do something else until the power and force limits are met. And as you can see on the left, the typical setup is of such a measurement is that you have the robot and the measurement device, and this measurement device must be fixed properly, because otherwise you won't get consistent results, and there the problem starts. Because in the real world you have different kinds of collisions. So basically you have the measurement itself or the collision itself, and there are differentiations according to the contact duration. So we have the transient contact, which is a very short contact, and the quasi-static contact, which is more like over a very long time. And you have to differentiate between if it's a clamping or a free collision. So you can see those two pictures in the lower part of the slide. So you can have a clamping situations. In this case, there is something behind the human body part, or you have a free collision. So if you have now, looking back to how this measurement is done today, you can see that with this measurement device, it's only possible to stipulate the biomechanics of a clamping collision. And the big question is now, okay, what happens now in a free collision? Because if you look at it very simple, you have two colliding masses, and with a fixed measurement device, the mass of the human body is clamped, so it's infinite. And if you have a free collision, this mass will be free. And if this mass is free, it also means that the collision forces are much lower, and you therefore have velocities or possible velocities that are higher in your collaborative process. But if you don't apply any method or do nothing and just use the fixed measurement values, then your velocity is lower than it must be to meet the requirements. And the idea was now from our side to develop a conversion method. And as we don't have that much time or are already overdue, I'm going to jump over a few slides. So basically what we have done, or go over them real quick, we have looked how does the mechanical body our model look like. We have then transformed it into a one-dimensional simulation model. And then we had an additional model abstraction. And in this model abstraction, we found out that there's a correlation between a fixed device and a free device. And what you can do is the collision forces of this fixed device can be converted into values of the free device if you know which masses are in this collision. So you need the mass of the robot and the mass of the human. So this simulations we've carried out, and we thought that this conversion method works quite good in theory, and that was the reason why we also started the experimental validation. So we put the biofidelic measurement device onto a system with rails, so it becomes a free moving measurement device. Of course, this kind of measurement device can only be used for horizontal collisions. And it's possible to apply different weights to this measurement device to stipulate different parts of the human body. So now I have some videos here of different kinds of collisions. Maybe let's, it's not possible to stop them with the laser pointer, but you can see the fixed measurement device on the top. In the middle, we had no additional weights on this measurement device, so the total weight was around 7 kilograms. And we have this lower video here, it's about 23 kilograms. And if you now look at collision or maximum forces during such collisions, we get different kind of measurement values. So what you can see here is the velocity on the x-axis and the maximum impact force on the y-axis. And depending on the velocity, also the impact force increases. And if you now, for example, have a limit value for a body part of 280 Newton, it means in this case with the fixed measurement that it's allowed to go at 280 millimeters per second. If you now have the measurement device or the free measurement device with 23 or 7 kilograms, this point here is crossed later, which means that your velocity you can go is higher. So usually if you test, you will only have the green measurement values. So we applied the conversion method we have developed to those green measurement values. And what we get is two new lines with converted values. And also with the converted values, you get a very high speed increase by 26 or even 33%. We carried out a lot of measurements and found out that in most cases our conversion method is conservative. So it means that you're always on the safe side because you're even slower than it would be allowed according to the experiments. So how does this conversion method then works in the praxis? So basically you are doing or performing the measurement of a clamping collisions. From this measurement, we extract the maximum clamping force, the mass of the robot. Then on the other hand, we have a dynamic human body model, which we have also developed within Rossini, but is not part of today's presentation. This dynamic body model calculates the mass of the human at the impact point. And with this conversion method, we can then estimate the free force. And then you can decide if it's safe or not if you compare it to the force limits according to the standards or literature. So that's already it for today. So what's the conclusion? So with this conversion method, it's now possible to evaluate free collisions with a fixed measurement device. It will give you a significant increase in speed, and it is thus safe. And this is, of course, very important. And you can also read about this work in a publication we had. You can see it is linked below. So outlook is also that we are trying to find methods to also estimate the impact velocity of the robot, because that's not always that easy. And yeah, as Morten has already introduced, this new method will also be part of this new ISO pass. So thank you very much. And yeah, if you have questions, feel free.
Thank you, Sebastian. Thank you very much. Are there any questions from our participants? I see no question in the chat. So I just would like to inform you that the registration of this workshop will be made public and available, so that everybody can, or people that could not join, will have the possibility to watch this registration in the following days. So if there aren't any questions, I thank all our speakers, and I know that some of them have to leave the meeting for other meetings. And so thank you very much for participating. I invite the Rossini partners to join me to the other workshop, to the other event that we are having today. So thank you very much. And of course, stay safe and enjoy also your summer holidays. Thank you.